Hello friends, continuing with 8th unit, Atom and Nucleus. Today we start with second chapter of this unit, that is Nucleus. It is the 13th chapter of the textbook titled as Nucleus. Now what is the strategy developed to learn this chapter? Here is the mind map. First, we'll take up the topic of nuclear force. Second, we'll take up the topic of mass defect. Third, energy release. Fourth, nuclear holocaust. Fifth, magic numbers. Sixth, radioactivity. And last, seventh, laws of radioactivity. So these are the 7 topics which we are going to learn in this chapter. Now we'll take up one by one. Now we take up the first topic, nuclear force. In order to understand this topic, we are to learn about some preliminary terms and their definitions. So let us take up one by one. First, we take up nucleons. Now what are nucleons? Let us try to understand. The constituents of nucleus, like protons and neutrons, are known as nucleons. I repeat, the constituents of nucleus, like protons and neutrons, are known as nucleons. Now second term, nucleon equation. If Z be the total number of protons and N be the total number of neutrons, then total number of nucleons, say A, would be given by the expression A is equal to Z plus N. I repeat, if Z be the total number of protons and N be the total number of neutrons, then total number of nucleons, say A, would be given by the expression A equal to Z plus N. Now the next term we have to understand is nuclide. The two nuclei with identical Z and identical N belonging to same nuclear species are called as nuclides. I repeat, two nuclei with identical Z and identical N belonging to the same nuclear species are called as nuclides. Okay. Now other terms, preliminary terms we have to learn is isotopes, isobars, isotones and isomers. So let us first understand isotopes. Nuclides with identical Z are called as isotopes. For example, H11, H21, H31 are the 3 isotopes of hydrogen. I repeat, nuclides with identical Z are called as isotopes. For example, H11, H21, H31, that is hydrogen, deuterium and tritium, are the 3 isotopes of hydrogen. Isobars. Now what are isobars? Nuclides with identical A are called as isobars. I repeat, nuclides with identical A are called as isobars. For example, stannous 11550 and indium 11549 are the 2 isobars because they have same A. I repeat, for example, stannous 11550 and IN indium 11549 are the 2 isobars being same in atomic mass, that is A is same for both. Now isotones, nuclides with identical N, are called as isotones. Isomers. Two nuclei of the same species, but in different energy states, of which at least one is in metastable state, are called as isomers. I repeat, two nuclei of the same species but in different energy states, of which at least one is in metastable state, are called as isomers. Okay. Now, after learning about preliminary terms about nucleus, we come to nuclear force. Now, what is nuclear force? We have to understand it. Now, protons, which are positively charged particles, do not like to stay together in a very small nucleus due to Coulombian force of repulsion, but they stay together. Now, question rises, why they stay together in such a small space? It means there exists another force which binds them to stay in nucleus and should be attractive in nature, that is, opposite to repulsive force. It is this force which is called as nuclear force. Now we define what is nuclear force. The force which binds neutrons and protons inside the nucleus against repulsive forces is called as nuclear force. And here in the diagram you can see force versus distance from center of nucleus curve, this is, and potential energy versus distance curve. Just you can see, mark the difference here from O to here this is R0. R0 is the distance between two nucleons up to which they can come near, and from O to R0 the repulsive force exists, and from R0 onward, from 2 to 3 Fermi from center, attractive force exists which binds these nucleons into the nucleus. Okay. Up to R0, which is the distance of closest approach, potential energy is maximum. Now, characteristics of nuclear force. First, it is an attractive force. Second, it is a strong force. Third, it operates between 2 to 3 Fermi distance from center of nucleus. Fourth, it exists between pairs, proton-proton pair, neutron-neutron pair, and proton-neutron pairs. So these are the four important characteristics of nuclear force, that it is an attractive force, strong force, short range force, and operates between 2 to 3 Fermi distance from center of nucleus, that is short range force. Exists between pairs, proton-proton pair, neutron-neutron pair, and proton-neutron pairs. Okay. The force versus distance graph. Here you have the force versus distance graph, and potential energy versus distance graph can be drawn as shown. Here you can see for R0 potential energy is maximum because R0 is the distance of closest approach of the two nucleons, where repulsive force dominates. Now assignment 30, question number 1. Define nuclear force and give its two important characteristics. Question number 2. Draw force versus distance from center of nucleus curve and discuss the nature of force. Number 1, when R is less than R0. Number 2, when R is more than R0. Thank you so much. Next time we'll take up second topic of this chapter, mass defect. Till then, goodbye and good luck to you.